Last but not least, in our table we have tetrahedral. And we know that tetrahedral has 4 bonds. So these two columns always add up to 4. Now, when we just have 4 bonds and all 4 of them have a gumdrop hanging out on the end as the substituents, then that's going to be a tetrahedral. So that would be an example like this. As you notice, one of them is almost directly over the central atom. So let me show you kind of at an angle here. So now I've got 1, 2, 3, 4 bonds. All 4 bonds have a gumdrop. Let me get that. There we go. And so since that's the same, it's going to be tetrahedral. Now, if I were to remove a gumdrop, so now when I look at it, there are 1, 2, 3 that bond and 1 that does not bond. And so when one doesn't bond, it's a trigonal pyramidal. And if you notice, if you kind of look at it without this one, it looks just like what we covered in another video. So you've got the 3 hanging out, so it's going to be a tetrahedral as a shape because you still have 1, 2, 3, 4 bonds, but it's going to be a trigonal pyramidal because it looks kind of like a pyramid now. Now, what happens if we take off another one? So now we're on this third example down here, and it says that we have 2 bonding pairs and 2 non-bonding. So as you notice, here are my 2 non-bonding, and here are my 2 bonding. So when I put the 2 that are bonding at an angle, you notice that it is a bent molecule. So it still has a shape of tetrahedral because I've got 4 toothpicks, but it's going to have a geometry of bent.